And now what you've been waiting for, part B of solving quadratic equations by graphing, where we get to estimate the solutions of quadratic equations by graphing. In the first two examples, we had happy integer answers. In the real world, things don't usually come out as integers. So we're going to solve by graphing. If integral roots cannot be found, estimate the roots by stating the consecutive integers between which the roots lie. Consecutive means in a row. To find our axis of symmetry, to figure out where to start our chart, we do our negative b over 2a thing yet again. Negative 4 would be 4 divided by 2 is 2. So they have two integers less than 2 and 2 greater than 2. Prepare to be amazed. We did not have 0 turn up in our chart, and yet, if you look closely, somewhere between positive 2 and negative 1, there is a 0. Somewhere between negative 1 and positive 2, there is a 0. The directions were solved by graphing, so we should plot the points and have our graph, but I had the answer from the table. The consecutive integers where our 0 falls between is between 0 and 1 and 3 and 4. Now watch out on the problem set because they're not opposed to having one root come out even and the other be between consecutive integers. Ooh, tricky. Shelley built a model rocket for a science project. The equation y equals negative 16t squared plus 250t models the flight of the rocket launched from ground level at a velocity of 250 feet per second, where y is the height of the rocket in feet after t seconds. For how many seconds was Shelley's rocket in the air? Well, GeoGebra doesn't like t as a variable, it prefers x, so I typed in f of x, or you could type y equals negative 16x squared plus 250x in the input bar, and it gave me the lovely graph, and I found the intersection using this little drop down right here. Intersect two objects, and I found it to be 15.63 seconds. And the question didn't ask for this, but in GeoGebra we could easily find the time and the maximum height that the projectile, aka rocket, hit this time. I use the wiggly equals for approximately. It's not exact. I'm rounding to the nearest hundredth. When you open up GeoGebra, if they ask you to do an update, do. It's added some nice new features. They always do. The roots of a quadratic equation are the x-intercepts of the related quadratic function, which may or may not be integers.